Yes, when I say a polynomial, I'm trying to mean that big term. For example, if we have a function in the form fx, the function is in the form fx is equal to n naught plus a1x plus a2 x squared plus a3 x cubed plus other terms there plus a term in an x to the power n, we say that this is a polynomial in x. When I say a polynomial in x, it means that we have very bigger terms. You see, for us or for you, you are used to these, you have been used to these equations up to like degree 2, yeah, or degree 3, but a polynomial can go to as far as any degree. That's why we end up with n. So it is a polynomial in x of a degree n, yeah. So we say that this function is a polynomial in x of degree n, where for this case, a is non-zero or is not equal to 0. So we call this, the function of this nature, a polynomial. We have a quadratic polynomial, we have a cubic polynomial, we have a quadratic polynomial, and very many others. So we shall look at how to multiply polynomials. We shall look at how to add polynomials. We shall look at how to divide. And basically, the main important thing will be dividing these polynomials. So immediately after showing you the quadratic polynomial, cubic polynomial, and the quadratic polynomial, we are going to rush direct to division of polynomials, where we have long division, and from there we shall go to the remainder theorem. So let's have like a part A of these polynomials, and it's where we normally have the quadratic polynomials, the quadratic or quadratics, quadratic polynomials, I can call quadratics. Now, if I let, of course, I know you have looked at roots of the equation. So if I let alpha and beta to be two roots, since my polynomial is in x, it means that x is equals to alpha, and at the same time, x is equals to beta. If I have these two, it means that when I get x minus alpha, it is equal to 0. These ones are, I think you have looked at them. X minus alpha is equals to 0, and x minus beta is equals to 0. So if I have these factors, then it means that x minus alpha times x minus beta is equal to 0. By expanding this, you will get what we call a quadratic polynomial. And how do we expand it? It will be x squared minus alpha x, or x alpha. Let me call it alpha x. X squared minus x alpha minus x beta plus alpha beta. Yeah, plus alpha beta, this is equal to 0. So by working on it, it will be x squared. Here the minus is common. I can factorize out alpha plus beta, and then x, then I say plus alpha beta, this is equal to 0. This is what we call a quadratic polynomial. Then, if you're looking at a cubic polynomial, cubic, equate part B, cubic polynomial. For this one, we shall let alpha, beta, and lambda to be the three roots. If I let them to be the three roots, then it means that x is equals to alpha, beta is equals to x also, or x is equal to beta, and still x is equals to lambda. It means that x minus alpha times x minus beta times x minus lambda, this is equals to 0. But remember, I've already gotten this as this. I've already gotten all that as this. So I'm just going to substitute it here, then I multiply x minus lambda. So I will have it as I'll have it as x squared minus alpha plus beta x plus alpha beta. I'm going to multiply this one with x minus lambda, and this is equal to 0. You may not be told to expand this one in an exam, but you need to take time and expand well. Of course, you have to first multiply x throughout this, then after you multiply lambda throughout that. So on so doing, you're going to come up with x cubed. I mean that here it will be x times this, which will be x cubed, minus x squared into x plus alpha, isn't it? Yeah, so it will be x plus, rather alpha plus beta, x squared, because it has multiplied here. Then this one, when you multiply it here, it is going to be what? Sorry, I've gotten x cubed. Yeah. It will be plus x alpha beta. Then you again multiply now by lambda. So it will be minus x squared lambda. You multiply it here, it is going to be minus alpha plus beta lambda x. Then you multiply it here, it will be minus alpha beta lambda, or lambda alpha beta. You rearrange that. You see, in some cases in pure math, we tend to miss some steps. Because now for like here, I can write and say it is x squared, x cubed, can say x cubed minus x cubed minus, the moment in this case, if you enter x squared lambda, yeah, you are going to find out that if you enter this alpha, rather lambda x here, you will enter it here, you also enter it there. So you like open up the brackets. It is going to reduce to, I guess, lambda plus beta plus, it is alpha plus beta plus lambda x squared. I want everyone to give it time and you expand it and you see whether you will get this. X squared then plus the ones of alpha beta, the ones with x only. Yeah, it is going to be alpha beta plus alpha lambda plus beta lambda x, then minus gamma, rather minus lambda alpha beta, minus lambda alpha beta is equal to 0. Everyone give it time and simplify it. It comes out automatically as a cubic polynomial. So that is how one can obtain a cubic polynomial. Then you can see if it's a cubic polynomial, the highest degree would be a 3, then it keeps decreasing, x squared x. Yeah, it was x squared x. But if it is like a quadratic polynomial, the one with the highest degree as 4, it will begin with x power 4, it goes to x power 3, it goes to x power 2, then it goes to x, then it becomes a constant. So that is what we call a polynomial. When we are introducing them, students think that they are very hard, but when you start long division, life becomes the easiest. Life becomes the easiest. So basically here, allow me say aquatic polynomial. I'm recording, I'm going to share the video because when we have to copy everything, we may not really do anything. But I'll go slow when we start division because that is where everything is going to be relying. Okay, so allow me say aquatic polynomial. The aquatic from quarter 4, we are trying to talk about the 4. So when you look at aquatic polynomial, here we shall let alpha, beta, lambda, and rho. Can bring in a rho. One can use gamma. Okay, if we let these ones to be 4 roots, it means that x is equals to alpha, if x is equals to alpha, still x is equals to beta, x is equals to lambda, and x is equals to rho. So it implies that when you're multiplying this one here, you're going to get x minus alpha times x minus beta times x minus lambda times x minus rho. This one should be equaling to 0. But we've already gotten all this up to this one. Bring it there. So in other words, this is going to be what we've gotten before. We had gotten x power 3 minus alpha plus beta plus lambda, then x squared, then we had alpha beta plus alpha lambda plus beta lambda times x, then minus alpha beta lambda. Then in this one, we are multiplying x minus rho to give us a 0. You first multiply x in this, in this, in that, in that. By multiplying x in this, it will bring out the x power 4. Here it will bring us the x power 3. Here it will bring us the x squared. Here it will bring us the x. Then after we multiply the rho in here, in there, in there, in there. So me, I'm writing the final expression. I want you guys to take your time and simplify it. But the final expression is going to be x power 4 minus alpha plus beta plus gamma plus rho x cubed plus alpha beta plus alpha lambda plus beta lambda plus beta rho plus lambda rho, and this is times x squared, then minus, we shall have alpha beta lambda plus alpha beta rho plus alpha lambda rho plus beta lambda rho, and all this one is going to be multiplied by x, then plus alpha beta lambda rho. This one is equals to 0. This is a simplification of what you get after you have multiplied this. You end up with this result. So this is a polynomial of the fourth degree. You can continue up to the time you want, but the more you go, the harder the simplification becomes. However, we don't normally even reach this side. As I've told you, this one is of low or of less significance in the calculations that are covered. So that is just a cheap introduction that maybe I can give you, and then we can build on this. We can build on this to do what we are supposed to do. Yeah. Now, after this, we are going to the most other interesting part of what we call the remainder theorem. Remainder theorem. From the remainder theorem, we go to long division. I don't want to waste much time in the things that won't hold pass. So, n, you can begin with n. You can begin with the remainder theorem, then you go to you can begin with the remainder theorem, and then you go to long division. Or you can begin with the long division, you go to remainder theorem. But to bring out the aspects very well, allow me begin with the remainder theorem. Let's first understand this remainder theorem very well, and then we see the remainder theorem. Here, that is where maybe your eyes have to be open if they are a bit closed. Remainder theorem. Now, if it's a theorem, so the theorem is proved by doing examples. So we say if, basically, I want to bring out something easy. If a polynomial, since a polynomial can be any function, let me call it fx or px. If a polynomial p of x is divided by maybe x minus a, if you divide a polynomial by x minus a, the polynomial is p of x. So if you divide it by x minus a, the quotient, we have what we call a quotient. So the quotient is 2 of x. Quotient is 2 of x, and the remainder, is r. Of course, when you divide something, I'm assuming, guys, we have what we are dividing. This is p of what? We are dividing p of x by x minus a. Okay? We are dividing p of x by x minus a. What you get here at the top is what we call the quotient. Then, of course, on division, these ones, in case you divide it and you don't get a 0, it means that it has a remainder. And what you get down here would be a remainder. Or the remainder, you can add it here plus a remainder. Now, what does it mean? It means that to get this polynomial, to get a polynomial p of x, this is a mathematical expression that we apply very much. P of x is the same as you get this times this plus a remainder, you get the polynomial. So the polynomial would be equaling to x minus a times the quotient of x plus the remainder. The moment you get what you're dividing, the moment you get what you're dividing by, you multiply it by the quotient, you add a remainder, you get the function, or you get the polynomial. In most of the cases, you find when this one which you're dividing, we normally call it a divisor, d of x. 2 of x, then plus a remainder. So that is always the general representation of a polynomial. To get a polynomial, for example, I'm assuming if you have 7 and you divide it by 2, you will get 3 and remainder 1, meaning that to get 7, which is a polynomial, in this case, which is what we are dividing, to get 7, you'll get a divisor 2, you multiply by the quotient 3, you add a remainder 1. That is what I'm trying to mean. So configure out this and compare it with this. You're going to find them correlating. If you're with me, members, type yes. If you're with me, type yes. If you're with me, guys, type yes. Very good. So I will keep repeating this. You just compare these two. Enoch, compare these two. Compare when you divide 7 by 2 and how you write the final answer if they need back the 7. To get 7, you get what you divided by, you multiply by the quotient, you add the remainder. That is the same thing I'm illustrating here. So me, I'm interested in these two aspects. Okay? I'm interested in that aspect. Now, from this, let me quote some other statement that when how should I configure it? When P of X is divided by, when P of X is divided by X minus A, we shall realize that the remainder is P of A. I want us to prove this, then we go to examples of finding the remainders, which is the easiest part. I will do question 1, we will say, let's do the rest by ourselves. Now, we are saying that when P of X is divided by X minus A, the remainder is P of A. Let's see the proof of that. Is that possible? It means that P of X is equals to what you're dividing with, that is X minus A, times the quotient of X plus the remainder R. Now, if you're the moment they say a certain polynomial is divided by X minus A, you must equate this divisor to 0. So equating the divisor to 0, equating the divisor to 0, it would mean that X minus A is equal to 0. Therefore, X is equals to A. If X is equaling to A, wherever there is X, go putting A. It means that if X is equals to A, it would mean that P of A, is going to be equaling to, this would be A minus A, which would be 0. So first say A minus A, because wherever X is, we are putting 0. Then 2 of A, then of course plus R. So P of A is equal to, this is 0 times 2 of A, that is 0, so is equals to A, meaning that the remainder is equals to P of A, and we have proved it. So allow me to take you direct to the examples. Examples are going to bring you a clear picture of what I'm trying to talk about. And then after you getting happy, you will say, sir, you continue. We don't have time to waste. All right. Examples, guys. Examples. I will do code 2, you do the rest examples. Find the remainders. Find the remainders when part A, 3x cubed minus 4x squared plus 5x, these are my polynomials, minus 8 is divided by x minus 2. B, when 2x cubed minus 3x squared minus 5x plus 6 is divided by x plus 2. C, when 2x cubed minus 7x plus 6 is divided by x minus 3. Finally, D, when x power 5 plus x minus 9 is divided by x plus 1. Now, members, as I've told you, I will do code 2 and we will do the rest because the solution is the same way. Now, solution. For you need to know in your mind that P of x is equal to quotient times the divisor plus the remainder. You get the quotient which is on top, you multiply it by what you are dividing by, you add a remainder, you get the polynomial. What does it mean? Of course, where 2 of x is the quotient, divisor, this is the remainder. I don't want these terms confused. And P of x is the polynomial. Allow me mute if you are not muted. Ochaya and Tumusime. Tumusime, maybe one day I will remove you from class. The moment I say you mute, you have to mute. Otherwise, that noise can disturb someone talking this side. So basically here, what you do, the first part, they have given me the polynomial px, p of x as 3x cubed minus 4x squared plus 5x minus 8. That is my polynomial. But they have given me the divisor as x minus 2. So d of x is equals to x minus 2. So equate the divisor to 0 should be another thing. So x minus 2 is equals to 0. If you equate the divisor to 0, you'll get your x as a 2. Interesting. After getting x as 2, you're going to substitute here and you get p of 2. So p of 2 is going to be equal to 3 times 2 squared. Wherever there is x, you'll go putting a 2. So 2 cubed minus 4 into 2 squared. Then plus 5 times 2, then plus 8. So the P of 2 is going to be, this is 4 times the, this is cubed, it is cubed. 8 times 3, that is 24 minus, this is 4, 16 plus 10 plus 8. 24 minus 6 plus 10 plus 8. This one will give you 10. But remember, we said that P of x or P of the divisor here is giving us the remainder. It means that the remainder here is equals to 10. As simple as that. It is minus 8, sorry. Huh? It's like, because I first put the examples down that I'm going to do. So that is what we do. I'm going to do another example. The one who has not understood the first one, you should understand on the second example. I said what you're given here is the polynomial. Equate the divisor to 0, get the value of x, substitute it here, what you get is the remainder. As simple as that. So part 2, let's do part 2. Part B. What is the polynomial for part B? polynomial, the function in x is what we call the polynomial. It is 2x cubed minus 3x squared minus 5x plus 6. That is the polynomial. But we are dividing it by, what is the divisor? Is what you're dividing with. The divisor is x plus 2. X plus 2. So if the divisor is x plus 2, we must equate the divisor to 0. So it means that x plus 2 is equal to 0. This one will give us x as negative 2. Substitute this value of x as negative 2 into this. The other proof which I made was not for fun members. It shows that the moment you get the value of x and you substitute in a polynomial, what you get is the remainder. So it means that now we are going to look for p of negative 2. Whatever x is, we're putting negative 2. So p of negative 2 will be 2 times negative 2 cubed minus 3 times negative 2 squared. I'm substituting where x is as negative 2. Minus 5 into negative 2 plus a 6. P of negative 2 is going to be equal to, when you work that one out, the answer I got is negative 12. P is negative 12. The value of P of that value of x that you get is the remainder, meaning that the remainder is negative 12. As simple as that. If you have picked, say yes, type yes. If you have picked something, type yes. If not, I do many. If you have picked, type yes. Let me do one more example. Example 3. We are given a polynomial of x. That function which they give is what we call a polynomial. It is 2x cubed minus 7x plus 6. That's our polynomial. But we are given the divisor. The divisor, the moment they say divided by, that is a divisor. A divisor is x minus 3. Equate the divisor to 0. When you equate the divisor to 0, x minus 3 will be equal to 0. It would imply that x is equal to 3. Then now you look for p of 3. It would imply that p of 3 is going to be equal to, wherever there is x, go putting a 3. So it is going to be 2, 3 cubed minus 7 times 3 plus 6. This is 27. 27 times this, 54. This is 54 minus 21 plus a 6. And you're going to get your P of 3 as 39. It means that in this case, the remainder is equals to 39. So the moment, and we shall prove these ones even by dividing, by wrong division, you will be seeing that the remainders are what we are getting. You can use this method or you can use wrong division to get the remainder. Now, it means that when you divide this thing by x minus 3, the remainder will be 13. As simple as that. If you have understood it, you can say stop so that I go to another thing. If you say stop, I'll give you numbers to do and I go to other things. I love math because math is just fun, but I don't love teaching it at school. I just hate teaching it. People are saying, sir, stop. Ooh, Olagawa, you stop there. But stops are few. Oh, yeah. Oh, my God. So, guys, you do the other number. You do the other party. You do the other party. Part 5. Part 4, sorry. You get me the remainder, x power 5. I want everyone to do it. Before I go to another thing, I want everyone to tell me the answer. Divided by x plus 1. I want an answer before we go anywhere else. I want an answer of that part before I go anywhere else. what do you get as the remainder for that question? If you get the remainder, you type it, and I see if we are fit to continue. I want to see if we are fit to continue. So that is how you can easily get the remainder without long division. But long division easily gives us, because that one you can get it without doubt. You get an answer, you type it there. Then afterwards, you are going to determine for me the remainder in your own time. Yes, Onenchan, David, you are getting the correct answer. Without wasting time, members, the correct answer is -11. If you don't get it, please don't blame me, but blame God. Just blame God, not me. So you can maybe add on this x squared plus 6x, x squared plus 6x plus 5 divided by x plus 2. I want you to get the remainder. We are going to prove these ones with wrong division. Then I want you to also get 2x cubed plus x squared, 2x cubed plus x squared, then plus 5x minus 4 divided by 2x minus 1. Now for this case, it is a bit hard, because you consider x minus 1, because when we say 2x minus 1, it would need us long division. This method becomes easy when you are dividing by a factor when the quotient of x is 1. But the moment you find that you have like 2x, 3x, it would call you for long division. Everyone who has gotten -11, please, big ups, big ups, big ups, big ups. I don't know why they say big ups, not big downs, but it is what it is. I continue. Let's go to obtaining the remainder by long division. Obtaining the remainder by long division. And after this, we shall have done a very great job. A very, very, very great job. I don't want you to give you that synthetic approach, because it is a bit confusing. If you can get the remainder by long division, you don't need to know what takes place in the synthetic approach. Okay. Obtaining the remainder by long division. That's where we are going. Obtaining the remainder by long division. Long division method. Of course, since you did some division in primary, I think this is the easiest stuff one can talk about. The easiest stuff one can talk about. So we are going to enjoy this. And after enjoying this, we shall go to mature questions, mature questions, mature questions. We attack UNEB, we do mature questions. The topic is the most enjoyable. And surprisingly, this topic, we can finish it in 2 lessons of pure math. Only 2 or 3, and without missing anything. So don't be like, no, we are rushing. The topic itself is very brief, and it can be done. By using long division, let's say by using long division, obtain remainders and quotients when part 1 x cubed plus 3x squared minus 4x minus 12 is divided by x squared plus x minus 6. Now, the other method cannot work because you cannot easily get the value of x here. It can be a bit hard. When you equate to 0, it means you're going to get 2 factors, which is a bit challenging. So, B, when 2x power 4 minus 8x cubed plus 5x squared plus 4 is divided by x minus 3. C, I will not do all, of course. 5x cubed minus 6x squared plus 3x plus 14 is divided by x plus 1. When 2x power 4 plus 6x cubed minus 7x squared plus 9x plus 11 is divided, plus 11, not plus 1, plus 11 is divided by 9x plus 11 is divided by x plus 4. E, when x power 4 minus 16 is divided by x minus 2. Let's go through these ones and you see how life is the easiest here. If you're ready, type yes, and I do. If you're ready, type yes, and I do. A few people are ready. Okay. Can I rub them? Members, I will do few and you do the rest. People are like, you rub, you are very late to rub. Okay, let me rub them. And I take you process by process. Question 1. If someone has copied them, you can post them in the group because we need to be really a bit serious and fast. 1. Allow me begin with part B with a reason. Allow me begin with part B, then after part B, I do part A. I want to first put you into the mood of this stuff. Let me begin with part 2. Part 2 is, it is 2x. I'm divide because we need long division. So I will divide. I'm dividing what? 2x power 4 minus 8x power 3 plus 5x squared. But we don't have the one of x. So you can say plus 0x. We don't have it. Because this, the degrees should be flowing. X power 4, x power 3, x power 2, x, then a constant. So our constant is plus what? Plus 4. Now, after that, you put the divisor here. My divisor is x minus 3. So x minus 3. After that, what do you do? After that, what do you do? What you do? You first look at the first degree or the first component, 2x power 4. All of it, you divide it by x. You don't divide by negative 3. Just divide by x. Everything we do, we'll be dividing by x. Don't divide by negative 3, I repeat. So when you get to x power 4, and you divide it by x, of course you get 2x cubed, isn't it, guys? You get 2x cubed. So we shall have 2 2x cubed. Then this 2x cubed, like the way you normally do when dividing, this 2x cubed, you will multiply it here and here. Now, during multiplication, you multiply it here and also here, so that you later subtract and you see what remains, then you continue. Now, when you get 2x cubed times x, you get 2x. You get 2x to the power 4, because you have gotten 2x cubed times x, you get 2x to the power 4. Then when you get 2x cubed times -3, you get -6x cubed. Then of course, these ones are done, we have multiplied. So here it's 0, 0, 0. So you can subtract that. When you subtract here, now don't start from this side. Start from here. 2x power 4 minus 2x power 4, that is a 0. -8x cubed minus -6x cubed. It will be -2x cubed. First will be -8x cubed minus -6x cubed. These ones will add and you get -2. Then 5x squared minus 0, because here we don't have anything, we don't have anything, we don't have anything. Even if you don't add these zeros. So we shall say plus 5x squared plus 0x. So we don't have any x. So it will be 0x, then plus 4. Even if one doesn't put a 0, provided you can understand it that it is not there. Then after that, still this is divisible by x. You will get now this term here. You divide it by x, -2x cubed. We are getting -2x cubed, guys. We are dividing it by x. This one will reduce this by 1. So we shall have -2x squared. So the answer here will be -2x squared. Whatever you get here on top, you have to multiply it in this one throughout. So -2x squared times x will be -2x cubed. -2x squared times -3, it will be +6x squared. Very interesting. Here we don't have anything. Here we don't have anything. We subtract again. It's better, maybe you can put the line and then you subtract. You can put the line and you subtract. When you subtract, we shall have -2x squared cubed minus -2x cubed. This is 0. This one will go. 5x squared minus 6x squared. We shall remain with the negative. Wait, guys. Am I correct?
Yeah.
Okay, let's see. I multiplied this to make +6x squared. I guess, yeah. Let's move together. So 5x squared minus 6x squared. It will be negative what? I'll remain with the -x squared. Plus 0x, 0, 0. It will keep 0. So plus a 4. Yeah, I'm just having a 4. But you can see that this -x squared can further be divided by x. When you divide this by x, you have -x squared, and you're dividing it by x, you remain with the -x. So here we shall have minus, shall remain with -x. -x times x, it will be -x squared. -x times 3. It will be -3x. -3x. We don't have a constant, so we can just subtract from there. -x squared minus -x squared, that means 0. Then this one, we don't have the x this side, so it will be 0 minus -0 minus -3x. Here we don't, here we have 0x plus 0x. Let me indicate it, maybe 0x minus negative 3x, it will be 3x. 4, this side we don't have anything. So 4 minus 0, it will be plus a 4. So 3x is divisible by x. 3x divided by x, we shall get plus 3. Plus 3 times x, this is 3x. 3x, rather 3 times negative 3, that is minus 9. When you subtract this one is going to be 0. Then 4 minus negative 9, it will be 13. But 13 cannot be divided by x, meaning my remainder is 13. So for this case, the remainder is 13. But the question wants us to obtain the remainders and quotient. So the remainder is equals to 13, and the quotient is equals to 2x cubed. The quotient is what you get on top, minus 2x squared minus x plus 3. If you've understood something, even if you have not excellently understood it, type a yes. I'm going to do another example, but if you have understood something, please type a yes and I see. If you've understood something, type a yes and I see. Good. Good, people understand. I love this. Math is the easiest subject in your combination. So if it is the hardest in your combination, there is a problem. Math is your easiest subject in your combination, unless you serve some God. But if you serve a living God, this one is the easiest in your combination. Now let me do part A. I want you to understand in that you can do them in your own time. Me, I want you to understand. That's why I'm not allowing you to copy them down. Part A now, we can do it very well. We are dividing x cubed plus 3x squared minus 4x minus 12. We are dividing it by x squared plus x minus 6. Whatever you're dividing, don't divide by any x, you divide by this one, the highest one here now. We shall be dividing with the highest one. For example, x cubed can be divided by x squared. That one you can really see it. X cubed, you can divide it by x squared. The reduced we shall remain with x. So we shall have x here. X divided by x, rather x times x squared. It will be x cubed. Now you multiply it everywhere, x times x, it will be x squared. X times negative 60, it will be minus 6x. Then of course here we have a 0 because we are not having anything else. You subtract. When you subtract x cubed and x cubed will make a 0. 3x squared minus x squared will make 2x squared. Minus 4 minus negative 6 to be plus 2x, I guess. Yeah. Then negative 12 minus 0, it will be minus 12. This one still, 2x squared, can further be divided by x. Yeah, it can further be divided by x. When you get 2x squared, we divide it by x, it is going to be plus 2. Plus 2. 2 times x squared, that is 2x squared. 2 times x, that is plus 2x. 2 times negative 6, that is going to be minus 12. When you subtract this, you get a 0 here, you get a 0 here, you get a 0 here. Meaning that remainder is 0. Remainder is 0. And the quotient of x is x plus 2. If you're with me, type a yes. Hey, life is easy. Life is just easy. If you're with me, okay, among the questions left, which one should I do for you? Because I want to do one more. Which one should I do for you? In the question is left, which one should I do for you? Which one should I do for you? Someone is saying D. A, B, C, D, E.
Okay.
Huh?
Me.
What is D saying? Because I've already removed them. Everyone is saying D. What is D saying? Someone to read it for me. You can unmute and you read it. What are we dividing?
Dividing 2x power 4. 2x power 4 plus 6x power 3. Minus 7x power 2.
You are delaying. I've processed it already. Plus 9x.
Plus 9x.
We are dividing it by what?
11. Dividing it by x plus 4.
Okay. That is the easiest, members. Just divide as usual. 2x power 4 by x, you get 2x cubed. 2x cubed times x, you get 2x power 4. 2x cubed times 4, you get 8x cubed. Subtract. X power 4 will go. You have 6x power 3 minus 8x power 3. You get negative 2x power 3. This is a 0 here. This is a 0 here. This is a 0 here. So you write the ones the way they are on top. Minus 7x squared plus 9x plus 11. Minus 2x cubed divided by x. It will give you minus 2x squared. Minus 2x squared times this to give you minus 2x cubed. When you multiply it by this, it will give you minus 8x squared. Plus a 0 here, plus a 0 here. You subtract again. When you subtract minus 2x cubed minus negative 2x cubed, this will be a 0. Negative 7x squared minus negative 8x squared, we will get x squared. Because it will be negative 7 minus negative 8, it will be positive x. So you have positive x squared plus 9x plus 11. X squared divided by x, it will be x. X times x, x squared plus x times 4, 4x. Then you subtract again. Of course, here you have a 0. When you subtract x squared minus x squared is 0. 9x minus 4x, 5x. 11 minus 0, that is 11. 5x can be divided by x to give you a 5. 5 times x, 5x. 5 times 4 plus a 20. When you subtract this, you're going to get 5x minus 5x, which is a 0. 11 minus 20, which is a 9. 9 cannot be divided by x. It means that the remainder is equals to 9, and the quotient of x is equals to 2x cubed minus 2x squared plus x plus a 5. One can write the final answer, even if one writes the final answer as it means that members 2x power 4 plus 6x cubed minus 7x squared plus 9x plus 11 is the same as, it is the same as x plus 4 times 2x cubed minus 2x squared plus x plus 5 plus the remainder, which is 9. This one will give you that. But they wanted us to be specific, as simple as that. Or a student can deduce by saying that 2x power 4 plus 6x cubed minus 7x squared plus 9x plus 11. The moment you divide it by x plus 4, you get 2x cubed minus 2x squared plus x plus 5, then plus the remainder, which is 9 out of x plus 4. When you are to conclude like this, it means you have to write the quotient. When you divide it, you get the quotient plus the remainder, which would have divided by this, but it is impossible. So even this kind of conclusion is accepted. This one. If you can do the rest, type yes. If you can do the rest, type yes. If you can do the rest, type yes. Someone is like, yo. So what I want to add on, the time remaining may not accept, may not allow, because I wanted to add on, the most crucial work, but the time remaining may not allow us to do that. The time remaining may not allow us to do that. Let me see. What's the time, guys? Someone has got a -9, is it? Do you get -9? You can go through well and see. You can go through and see. I'm checking out something here. Okay, what I know, in our next lesson, these ones will be finished because, okay, if it is -9, yeah. It is 11 minus 20, which is -9. That is okay. That is okay. So at 3:30, I see, as per the timetable, I think these students will have left school. The teacher will be available for biology. At 3:30, we shall connect. I will coordinate with you on the group. You will share a link with me because the one preparing for that lesson of biology. So the teacher is going to send a link, which link I will share with you. I want you to test the bite of that man's biology and you see what it means. Good. Okay, so guys, I won't add on anything there, but the work remaining on this topic is the most interesting work, whereby the number of UNEB last year, after next lesson, you are supposed to chop it all. UNEB of last year, number 13, was about polynomials. Very, very, very cheap. Like this is among the cheapest topics, this one and the binomial theorem, but we shall go slowly. I don't know what members you have done to bring your colleagues. You bring your colleagues on board. Bring your colleagues on board. I clearly indicated that the ones who will join from next week, since they will have studied 3 weeks, the payment would be a 70, just a 70. So try bringing your colleagues on board. Let them come and attend. At least, actually, I thought that this class will get to over 30 or 50 students. And I don't know why our things at our school are always behind. There is a school which has reported, I already have 52 students. The lesson which I have after lunch, 52 students. 52 students and only math and chemistry. For them, they will be studying only math and chemistry, but they're already 52. So you do the needful, guys, and convince you guys, your colleagues, to join. I wish you the best. At 3:30, I will send you a link before that time. Then you have a biology lesson. Okay, good time.